So in this question, we've been given a diagram. We want to firstly show that these coordinates are pi and 3 and root 3. So we solve the two simultaneously. Tan of x is equal to 2 sine x. So if I change sine of x to cos and tan of sine x on cos x, we can see that from that, divide by sine and multiply by cos, if you'd like, then 1 would equal 2 cos x. So that's what it must be equal to for these two to be the same. Again, then cos x must be equal to a half. We're between 0 and pi and 2, so there's only one solution because it's in the first quadrant. So it'd be pi and 3. If that's the case, sub pi and 3 into either of those equations, you get root 3. So there's our point of intersection. And seeing that shade area, you might be thinking, well, we want to find some area. Firstly, though, we want to find the derivative of natural log of cos of x and show that it's equal to minus tan of x. So when we derive a log function, we get the derivative of the function over the function. So derivative of cos minus sine over the function cos. Sine on cos gives us minus tan. That's why we don't ask you to integrate a tan function, because it goes back to natural log of cos. So, and yeah, that's just a little bit too hard for at a 2-unit level, and we're not worrying about that. So what we want to do is hence use what we've done to find the shaded area in the diagram. So if we look at that, we'd have the top curve, which is sine of 2 sine x, minus the tan of x, and so it's going to be between 0 and pi and 3, because we found those values there. So we found our points of intersection. So that's the case. We get 0 to pi and 3. There's our integral. We integrate 2 sine x, integrates to minus 2 cos x, and minus tan x integrated to natural log of cos of x. So that's why we just able to put it straight back in there, because we found the derivative of natural log of x before. We're going between 0 and pi and 3. We do our substitution. Cos of pi and 3 and minus times the minus 2, natural log of cos of pi and 3. Cos of 0, natural log of cos of 0. Now, we do those values. Cos of pi and 3 is a half. So cos of pi and 3 there is a half as well. So we take natural log of a half. The minus 2 times the half gives us 1. That gives us minus 1. And with the positive 2, because minus gives us a positive. Cos of 0 is 1, so it gives us, that's where the 1 comes in, and it's positive. And the 2 minus 1 here gives us 1. Cos of 0 is 1, so natural log of 1, 0, we're going to ignore it. So that's why we just end up with 1 plus natural log of a half. And if you really want to, you can write that as 1 minus natural log of 2, because that's 2 to the power of minus 1. And you can bring the power down and just make it a minus there. And you have natural log of 2. I'm quite happy if you wrote that, like we write that unit squared, it's all good. You got it right. So just be careful. And that's a tricky one. That's not an easy question, but there's lots of parts that you've got to realise. But again, those higher bands, these are the types of questions you're going to have to see and solve.